All right, thank you so much for joining us today. Let's go through this worksheet together, right? So the first one, we just need to, do some sketch and then finding the distance and how far the thing will go, right? So from the first one, the car, we have the 60 mph and then in 2 hours. So this is the speed, or let's say the velocity, and this is the time. Same thing here. The velocity is here and then also the time is here. So let's try and sketch something. So if I have my y-axis and I have my x-axis, good. Then from the first 2 hours, I'm just going to go with time and then the velocity right here. So this is what I'm going to do. Then the first 2 hours is going with 60, and then the second 2 hours, so when I add it becomes 4 hours, is going 40. So it means that my graph at 2 hours and 40 is going to be something like this. So I'm going to have something like something like this, and then also something like this. But I know that speed is equal to distance over time, right? So if I'm naming this one to be s dt, now speed can be the same as the velocity, right? Also, let me use the vin here. Then if I'm thinking about finding the distance, then this implies that distance is equal to the velocity times what? Time. So now with this first box that we have here, what is the distance? The distance is speed times the time, right? So I'm going to have 120, and then the second one is the distance here, which is 2 here, times the speed also here, which is going to give us 80. So the whole distance that the car is going to travel is going to be, so let's assume that this is the first distance and this is the second distance. Then the total distance is going to be distance 1 plus distance 2, which is 120 plus 80, and this is going to give us 200. Nice. Now let's look at question 2. Now, kind of this, we just need to like love drawing. If you don't love drawing, it means that you get stuck here. So let's try and sketch something here. So I will try and present all the information on the diagram here, and then we see what we can do. So we have this one also here. So we have time and we have the velocity, right? So let me put the velocity here, and let me put the time here. So the time we have at 0, at 2, at 4, at 6, at 8, and at 10. Right. So let me just put the sketch on it. So at 0 we have 20. So I can have 20 here. At 2 we have like 30. Let me say 38. Let me say here will be 34. Let me say here will be 48, and let me say here will be going to be 50. So our coordinates is 0 and 20, 2 and 3, 0, 4 and 3, 8, 6 and 4, 4. We have 8 and 4, 8. The last one is 10 and 50. So this is what you are going to have. So it's kind of, we have something like this, something that is going through here like this, right? So we have a line passing through other point. So since I'm using red, let me make this one black. Good. And then we have point coming down here, another point here, another point here, another point here. So now we have this graph. The first question is we need to approximate the left. We need to find the left-ended approximation. So the left-ended approximation is basically the one below this line here, right? So let's try and do that. So we are going to have something like this. Um, this one here, right? We are going to have this one here. We want to approximate. We want to approximate this one too, and we want to approximate this one too. So the idea is that we want to like kind of we are finding the area here, right? So what we need to do is for us to find the area, what we need to do is like we are trying to divide them into small pieces so that we can do the approximation. So now what we need to do is now this line right here, we need to look at the change in time. What's the change in time? Remember, this is the time here. So what is the change in time here? The change in time here is 2 because 0 minus 2 is 2, 4 minus 2, 2, 6 minus 2. So the change in time is like constant. So 2, 2, 2, 2, right? So the left ended approximation is going to be 2 times the velocity here plus 2 times the velocity here. So like kind of we are looking at the distance in here. So the distance here will be like 2 times this, 2 times this, 2 times this, 2 times this, and 2 times this. That's what you are going to get for the left-ended approximation. So what are we going to get? We are going to have 20 times 2 plus 30 times 2 plus 38 times 2 plus 44 times 2 plus 48 times 2. And this should be equal to, when you do the multiplication, you should have 360. 360. So multiply this by this, this by that, this by that, this by that, and this by that. Now the right-handed is the one above the graph, right? So the right is like we need to move above, right? So what we are going to do is the above, let me use something like blue. So the above is going to be like we are finding the distance from here to here, right? And then we move up and then we get another distance here. We move up, we have another distance here. We move up, we have another distance here. We move up and we have another distance here. Right. So this is what we are going to do. So the right, we are starting from the one here. We are starting from here. So 2 times 50, 2 times 48, 2 times 44, 2 times 38, and then 2 times 30. So that's what you are going to get. So we are starting from here. We are starting from here where we ended here. So going. So we are going to have, this is going to give us let me use red. This is going to give us 2 times 50 plus 2 times 48 plus 2 times 44 plus 2 times 38 plus 2 times 30. So 2 times this. So we are using the change in time to multiply the velocities. So this one, when you do it, you need to have 440. So the idea is that if you are finding for the left-handed, like kind of you are summing all the velocities times the change in what time. So velocities, like you are summing all the velocities times the change in time. But you see, this one we are lucky enough to see that the change in time is the same thing. So what you can do is if you can add 20 plus 30 plus 38 plus 40 plus 48 and you just multiply by 2. The other one 50 plus this plus this plus this plus this. They will multiply by 2 because the change is the same. And when the change is not the same, then you need to do what we are just doing here. Multiply the change in time to 8 what? Velocity. Yeah. So that is what you are going to get for the first one. All right. Let's look at this one. So this one, you need to read the question. Today, when my student, when they were doing it, when they just saw the question, they started doing the integration. This is equal to um, 2x squared divided by 2 plus x. Then they do like 1 and 3, and they just doing substitution. I was like, You need to read the question before you just start doing it. So this one is saying that we should use the area formulas. We shouldn't use the antiderivatives, right? So it means that what we need to do is here we need to pick the function, which is here. Remember, this is a function, right? Like kind of this is the f prime function, but we are assuming that this is f of x, right? Because anything that you have under the graph is like f prime. But we are going to assume that this is f of x. So let's assume that f of x is equal to 2x plus 1. And then we have our x value. So let's assume that x1 is 1 and x2 is equal to 3. So let's try and have a table, have our x and have our f of x. So x is 1 and 3. When x is 1, what do we get from here? We are going to have it to be 3. And then when f is, let's say, 3, when you plug it in, you are going to have 7. So let's sketch. Now here, when you are sketching the graph, make sure you sketch them and then you shade the right portion. Right, so let's try and sketch this graph here. So I have this one here. Now I have when x is equal to 1 and I have when x is equal to 3. So when x is equal to 1, we saw that we are going to have 3, and when x is equal to 3, we are having 7. So remember, when you are done, now 1 and 3 is going to be somewhere here. So what I need to do is I need to join my line where I have it, and then 3 and 7 is somewhere here. I need to also have it like this. So the idea is that now I have this, I have this, I have this, I have that. So the only point for me to do is I need to close this graph here. So I'm going to close it like this. And the area that I'm looking for is actually this is what I'm looking for. We need to find the integration under this. Right. Now, if you don't know this shape, then what you need to do is you try to divide them, right? Good. So I can try to divide this shape into 2 so that what I'm going to get is I'm going to have area 1, area 2. So I can see that the area 2 is like right angle triangle, but the down, I don't know whether it's a square or triangle. So what I need to do is I need to find the distance. So what's the distance from this side to this side? Now 3 minus 1 is going to give us 2. What's the distance from this side to this side? Remember, here is 0, so 3 minus 0 is going to give us 3. And then we know that this from this side to this side is actually 7. But we want to know the distance here. So distance here is like 3 and 4. Sorry, 3 and 7. So 7 minus 3 is going to give us 4. So the distance from here to here is going to give us 4. So this one will help us to find the area. So area 1, we can see that since they are not the same, this is rectangle. So what's the formula for finding rectangle? Let's say base times height. So 2 times 3, and we are going to have 6. Area 2 is, this is right angle triangle, where the base is 2 and then the height is 4. So we know the formula for finding right angle triangle. So 1 over 2 base times height. This is 1 over 2 times 4, and this is 4. So the area is A1 plus A2, which is going to give us 10. So it means that when we do the integration here, we need to have 10. So that is basically what we are trying to say. Like when I do the function, I should be able to get it to be 10. So that is the idea. So you see, that is somebody can know the form of this one and just use the formula for calculating this shape and just do it right away. But I like dividing them into 2 to have either right angle or triangle and take it from there. So that's what I'm going to get for the A. Let's look at B. Same idea. Let me assume that this is gen of x, which is equal to 2x minus 2. Then I draw my table. I have x is 0, x is 2. Then I have my gen of x. What is gen of 0? Gen of 0 is going to give us -2, and then gain of 2 is going to give us 2. So let's try and sketch. So I'm trying to sketch something here. So 0 is here, and I need to have -2. So I'm going to have it to be -2. Let me put my -2 here. So this is where the point is going to be. So it means that my line will be on this. Good. I have 2. 2 goes with 2. So let's assume that 2 is here. I'm going to have my point to be this. So this is going to give me something like this. So now what can I do? Remember, always we need to make sure that the point that where the ending point shaded is like we are constructing them together. So I'm going to have something like this. This line is going to meet this line here. So it means that where I need to shade is here and then also here. So I'm going to shade this one here. I'm also going to shade this one here. So you can see that the area that we are looking for is this and that. So let's say this is area 1, this is area 2. Good. So what are we going to do? What is area 1? We can see that this is in the form of like right angle triangle. What is the distance here? Now the distance here is like 2 because from 0 to 2. So we are going to have something like 2, the distance here. What's the distance here? The distance here, we don't know. So what we need to know is this line here that we are having here. This line that we are having here is actually gen of x is equal to 2x minus 2, right? So for us to know this point here, then it means that at this line is when s is no y is equal to 0. That's the horizontal asymptote, right? So the y is the same as gen of x in this case. So like we have 0 is equal to 2x minus 2, then 2x is equal to 2 and x is equal to 1. So if you assume that it's 1, yeah, it is 1, but always try and then solve them simultaneously before you get what we have there. So it means that the distance here is 1, the distance here is 2, the distance here 2 is also 2. So let's find area 1. Area 1 is equal to half base times height. So this is going to be 1 over 2 times the base is 1 times the height is 2. This is going to give us 1. Area 2 is equal to 1 over 2bh, which is equal to the same thing times 1 times 2, which is equal to 1. So what is the area? Now the area is equal to, now remember area 1 is below the what? The x-axis. So anything below the x-axis, we are going to negate it. So we are going to have negative a1 plus a2. So minus 1 plus 1, and we are going to get it to be 0. So you will see that when you integrate this, we are going to have 0. So that is the idea with the integration that we want to work with. Oh, this my worksheet is so nice with colors and stuff. Wow. Yeah, so this is going to give us 0. So you can just do the integration straight away to confirm your results anytime you use something like this. When you finish, try and integrate to see if you are going to get the same results using the areas, right? So now let's look at question 4. So question 4, we want to estimate the area under the line x-axis. So x-axis is like and then this function here between s is equal to 2 and that. So let's try and plug in the function x. So I just want to draw something here. So I have my x here, and then I have my f of x here. So x is 2, x is 6. I'm going to have f of 2 to be equal to, so when I plug in 2 here, this is going to give me 30. And then when I plug in 6, I'm going to have 10, I think. Yes. Right. So let's try and sketch. Always we need to sketch. Now here, what we are going to do is we are trying to sketch this one, but we need to divide this one into 4 rectangles, right? So let me try and sketch this one here nicely. So I have this, oops, I have this, and then I have that. So the endpoint here is 2 and 6. So let's assume that this is 2 and this is 6. But the idea is that we want to divide this one into what? 4. So we need to find the distance here. What is the distance here? 6 minus 2 is 4 divided by 4, because we want to divide it into 4. So it means that this one is going to give us 1. So for us to divide this one into 4, we need to just go 1, 1, 1, right? So this one will be 3, this one will be 4, and this one will be 5, right? So since now we have gotten 3, 4, 5, then we need to also look for f of 3, f of 4, and f of 5. So that is how you can also be doing the graph too as well. So now what is f of 3? What is f of 3? What are we going to get for f of 3? So f of 3, 60 divided by 3 should give us 20. And then f of 4, we should have something like, I think, 15. Yeah. And then f of 5 should give us 12. So we are going to plot this on the graph. So let's say f of 2 is 30. So we have 30 somewhere here, right? So let me just make it 10. Let me shift there. Let me shift this one small so that my graph will be nice. Good. So 10, 20, and let me say here is 30, right? So 2 and 30 will be here. 3 is 20, so 3 and 20 will be here. 4 is 15, so 4 and 15 will be just like in the middle here. 5 is 12, so kind of also almost above this. And then 6 is 10, so we are going to have this form. Right. So let's try and then draw the graph. So I have something like this. I have something like this. Oops. So let me just do something like this. Right. I have something like this. I have something like this. I have something like this. Then have something like this. So my line is like going to pass to something like this. Good. That will be my line. Let me just bring my point again. So this point is like this point is when we have 2 and 30. This point is 3 and 20. This point is 4 and 15. This point is 5 and 12. And no, yeah, 5 and 12. We have 5, yeah, 5 and 12. And this is 6 and 10. Right. So now we are done with the graph, but the question is we should find the left-ended. So remember the left-ended is always down here, right? We need to go down, 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 and down, right? So that is what we are going to get for the left-ended. So what will be the distance between the change in time, right? So what's the distance between here? So 6 minus this one is going to be 1. 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 Right. So this is what you are going to get because we are between 2 and 6. So let's do the multiplication. What are we going to get? Remember, we just need to start multiplying it from the left. So we are moving from the left, right? So the left-ended is going to be 1 times 30, 1 times 20, 1 times 15. This is 15. And then the last one will be 1 times 12. So always the left ended, you start from here and then you just move. this with the first one. If you start from here, you see that you are going to include this, and the time you get here, the ones is finished. So you not multiply by this. So this is going to be 1 times 30 plus 1 times I think 20 plus 1 times 15 plus 1 times 12. Let me just write it bold for you. So 1 times 30. So 1 times 30 is, okay, you let me just write 1 times 30 plus 1 times 20 plus 1 times 15 plus 1 times 12. And this one should give us 7, 7. So that is the, when you divide the rectangle into 4, and then you want to do that. Now let's look at the next one. So the next one, we are going to divide the rectangle into what? 8, and then that one we are going to go with the right ended, right? So same thing, we need to sketch. So this kind of, we need to do a lot of sketching. So we have f of x, and then we have our x again. So we need to have them here. So we have the f of x here. So we need to pick the endpoint 2, 2 and 6. So 2 and 6, we saw that it's going to give us 3, 0 and 10. So now let's try and divide it into 8. So when we divide into 8, remember, when I'm drawing the graph again, now I'm going to have this here, and I'm going to have this here. Now I have my 2, I have my 6. Now since I want to divide it into 8, 6 minus 4, 6 minus 2 is going to give us 4, and 4 divided by 8, so 4 divided by 8 is going to give us 1 over 2. So it means that we need to go by 1 over 2. Like we need to add, the change will be 1 over 2. So this is going to be 2.5, 3, 3.5, 4, 4.5, 5, and then 5.5 and 6. So this is how we can find this one. You just find the difference, then you divide it by the number of triangles that you want to make. So it means that we need to look for 2.5, 3, 3.5, 4, 4.5, 5, and 5.5. So we need to plug them inside the function to also get their corresponding value. So remember, the function is like something divided by 60. So here, since I'm not using calculator, this is going to be like 60 divided by 2.5. 60 divided by 3, I think that one we can just do the computation and just have 20. Then we have 60 divided by 3.5, and then 4 goes to this one, I think 15. Is it 15? The 4, we had 15, yeah. So this one is going to give us 15. And then this will be 60 divided by 4.5. And then 5 goes to 60, I think 12. Yeah. And then this one will be 60 divided by 5.5. Right. So this is what you are going to do. So the same idea, we are starting from 10, 20, and then 30, right? So let's try and sketch. 2 is going to give us 30. 3 is giving us 20. 4 is giving us 15. 15 will be in the middle somewhere here. 5 is giving us 12. And 6 is giving us the 10. So the rest will be in the middle, right? So if 2.5, it means that 2.5 will fall between this interval here. So let's give it somewhere here. 3.5 will be somewhere here. 4.5 will be somewhere here. And then 5.5 will be somewhere here. So we are going to have our graph to be of this form. Yes, very nice. So we have this point, we have this point, we have this point too as well. So now the question is, now we need to move right-ended, right? So we are just moving above, like we are trying to move above. So right-ended, it means that here when we are doing it, we are going to start from the right and then we move to the end. So if I have this, or let me just use dot 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 dot. I have another dot line here. Good. So what is the change? Remember, we've already calculated the change and we are seeing that the change is going to be like 0. Um, 0.5, right? That was the change that we were looking at. So we are looking at the right-handed. So this is what you are going to get. So we are going to get. So the change is 0.5, 0.5 throughout, right? The change is 0.5 throughout. So what we are going to do is now, what we are going to do is now we are going to start from the right. So we are moving from this side to this side. So don't forget, we need to start from here and then we move towards this. So it means that we are not going to use the 2, the last point here, and it's what? F of x. So it means that we are not going to use this. We are not going to use it. So what we are going to do is we are going to multiply this one by 2.5, this one by 2.5, this one by 2.5, this one by 2.5, the same thing up to the last point. So let's do that and see what we are going to get. So we are going to have 0.5 times the 6. The 6 is like 10 plus 0.5. The one for 5.5 is 60 divided by 5.5 plus 0.5. The one for 5 is 12 plus 0.5 plus 0.5. The one for let me see the one for 4 point, this one is going to give us 60 divided by 4.5 plus 0.5 times the one with 4 is 15 plus 0.5 times the one with 3.5 is 60 divided by 3.5, and then plus 0.5. The one with, let me say, the one with 3 is going to give us 20 plus 0.5. The one at 2.5 is going to give us 60 divided by this. And then when you punch everything on the calculator, you should have something approximately 61.19. So you can check that on your calculator, right? So that is the idea. So when you are dealing with them, when you are moving from the right, it means that the last point, you are not going to include them. So you just need to just multiply the change to the rest of them. Then when you are moving from the left, you are not going to include the last point. So you just multiply the change by the rest of the function here. Good. So I think we've made use of the C place. So what I'm going to do is, now we want to now work with the C. So let me just clean, I just want to clean this solution here. So let me just, the final answer is this. Let me just bring it here and just clean this one. Now with this one, now we are talking about midpoint. So the same idea, but here we are going to divide it into 2. So let's pick the same f of x, and then we are going to have something like same 2 and 6. So 2 and 6, we are having 30, and then we are having the 10. But here we want to look at the midpoint for the height. So since we want to divide it into 2, let's draw the graph. We have 2 here, we have 6 here, right? So the same thing, this minus this is 4 divided by 2 is going to give us 2. So from 2, it means that the change is 2. So from 2, we move to 4, and then 6, we are done. So let's look at 4. We saw that 4 is 15. So this is like 10, 20, and we have our 30 here. So 2 is giving us 30, 4 is giving us something like 15 somewhere here, and this guy is giving us this. But here we are looking at the midpoint. So that's what you need to know. Here we are looking at the midpoint. So let's try and find the midpoint and see. So I'm going to have something like this, right? I'm going to have something like this. I'm going to have something like this. Oops, oops. I'm going to have something like this. Now remember this, let me even clean this one. We don't have this because this is not part of the what we are looking for, right? Because we are looking from 2 to 6. So the midpoint, when you say midpoint, midpoint should be like the one in the middle here, and the midpoint should be the one in the middle here. So what will be the midpoint? So midpoint is like you find the distance, you divide it by 2. So 4 minus 2 is like 2. 2 divided by 2 is 1. So the midpoint is like going to be 3 because it should be 1. So this is where we are going to get our midpoint. Midpoint here absolutely is also going to give us 5, right? So this one will be 3 and the midpoint here will be 5. So this is what you are going to get. So here what we are looking for is, now we are looking for the graph that goes through the midpoint, right? So we are looking at the graph that goes through the midpoint. So this is what we need to do. So now, since we are using the midpoint, then now let's look at the coordinate for the midpoint. Here is 3, and so we need to look for now the coordinates for the midpoint, 3 and 5. So what it will be 3? When I divide it by 3, 60 by 3, I'm going to have 20. And when I divide it by 5, I'm going to have 12. Right. So now this is what we are getting now. And what we need to ask ourselves is, now what is the distance? We remember that the distance between this is 2, and then the distance between this one too is 2. So the midpoint distance is going to be 2 times 20 plus 2 times 12. And this should give us 64. So now we know how to do with midpoint. So midpoint, we are not looking at the endpoint. So he said that this one is the endpoint. So we are looking at the endpoint. This one is talking about the midpoint. So we need to look at the midpoint in the triangles. And then we just pick it from there. So this is the question 4. Let's look at question 5. So we saw that from here that the integration for this one is actually the area for this, so that it will help us to do the question 5, or the question 5. We saw that for us to integrate this, then we need to integrate from 1 to 3. So we are just looking at 1 to 3, then we look at the area here, and we had 10, and we are saying that this is equal to 10. Same thing for this one too. So let's look at how we are going to also consider question 5. So we have this graph here, and we are saying that the area for this, the area here is 4 from the question. Then the area for the B is 6, and then the area for C is 5. But don't forget, anytime the area is below this one, is going to be negative, right? So here is like, it implies that since it's below the x-axis, this should be like -6. So that's what you need to know. So now what is the area here? The area here is like the one from 0 to 1. So we can see that this is 0. So from 0 to 1, the area here is 4. So we are just going to have 4. Very simple, right? Then we need to look at the area from 1 to 7. So 1 to 7, we can look at the area between, we can just integrate from 1 to 5, and then from 5 to 7. So it means that we need to add area B plus area C. So what is area B? Area B, because it's below, we are going to have -6 plus area C is 5, and this is going to give us -1. Right. So for us to move from 1 to this one, we can move from so let me just write this one well for you, or let me just shift this one small. So this one is going to be like, For us to move from 1 to 7, we can move from 1 to 5, f of x dx, plus now moving from 5 to 7. So this one will be f of x dx is equal to, so now moving from 1 to 5 is the area B, which is here, and then moving from 5 to 7 is area C, which is also here. Then I add and get the 7 here. This is equal to 3. So this one we have moving from 0 to 7. So what we can do is, this can be written as, I'm going to split this one because we've done the A and B, right? So this is the same as moving from 0 to 1, f of x, plus moving from 0 to 7, no, moving from 1 to 7, f of x dx. So you see the way I splitted the integration, moving from 0 to 1, then 1 to 7. The reason why I splitted this one into this is like, now this one is here, which is 4, and this one is also here, which is also minus 1. So I can just write this one as 3 times 4 minus 1, and this is 3 times 3, which is equal to 9. Another way that I can do this is I can split this one from 0 to 1, f of x dx, plus, so now from 0 to 1, then from 1 to 5, so from 1 to 5, f of x dx, plus now from 5 to 7, then I'm going to have from 5 to 7, f of x dx. So you see that it is continuous, 0 to 1, 1 to 5, 5 to 7. So now what are we going to get from here? Now we are going to have 3. What is the area here? So we saw that the area here is 4. So we are going to have 4. What is the area between this? This is -6. So we have the -6 plus the area here is 5. So 5. So we are going to have 3. And then this is going to be 3. And we are going to have the same 9 there. So that is how we can also utilize, finding area under the curve. That's actually the integration that we are doing. So if this one was the graph that we drew, we drew, right, like drawing it, we drew, then now what I need to do is, if I want to find the area for this, I'm going to use the area for right angle triangle, right? So half base times height, the same thing here. So let's assume that I don't know the area formula for finding area of, let's say, triangle. Then I can divide this one into 2, so that I have right angle triangle. I solve the area for this, I have solved the area for this. Then when I add to get the B, and then you take it from there. All right, so now you can have fun with question 6. Just doing some substitution here. So just plug in 1 inside this, 4 inside this, and just have some fun. Sure. All right, see you in the next video.